Hello everyone, welcome to the channel. In this video, what I was planning to do was I was planning to write a small bootloader, a simple not a bootloader, a simple kernel, and then simulate how the booting process work. But in this video, we have to skip that step and go to that step in the next video because I found that we haven't loaded our kernel yet because we also haven't defined it. But before defining it, we need to set instruction in the bootloader uh, so that we can load that kernel in the memory. So the bootloader each in sector 1 of disk, and the kernel each in like sector 2. And you might be wondering, how does that happen? Like we will manually do that using NASM, but uh, in the normal computer, that is how it is already stored. So while booting, BIOS automatically loads the sector 1, that is bootloader, into like 0x7C00, like the starting address of the bootloader in RAM. And our bootloader should be able to load that kernel that we will be writing. So in our case, we will be making only 512 bytes of kernel. So our bootloader should be able to load kernel into 0x10,000. And this loading should be done in real mode, because we need to use the interrupt given by the BIOS, and it is only available in the real mode. So reading from the disks or like writing to the RAM, it's similar thing, and it should be only be done in the real mode. So let's get started into the coding. So first of all, we have to use the cylindrical head sector method, that is called CHS method, to read from the disk. So first of all, what I will do is I'm gonna write something over here that I will explain in a few minutes. So I'm gonna write kernel low kernel load seg equals to being 0x100, and after that uh, uh, kernel sectors EQ equals to 1. That means we only want to read the one sector. And you might be wondering, like, this address and this value and this value is quite familiar, but this is the actual address of the PML4 table, but this is also actual value, but this is used in segmentation. And if you remember, it is multiplied by 16. That is, it is the one zero each added, one hexadecimal zero each added on the right side. So it will be very much different than the address. So after that, what we will do is, in this, after we set up the interrupt, we will create a memory space where we can uh, um, uh, right, where we can store the drive number that our BIOS passes us to in the DL register. This boot drive number specifies the drive booting device. Like if you have SSD hard drive and you are booting from the hard drive, you should have some number that represent that hard drive. And also so that you could load the kernel from the uh, same disk, same hard disk. So that is the concept. So over here, what I am going to do is I'm gonna create a label called boot drive, and over here I'm gonna define a byte, just a zero. And just after that, as I have told you, the BIOS passes the number in the DL register. So I'm gonna do the Exactly same over here. So just few ups ahead and move boot drive to contain the value of DL. Now that we have DL, it will be used while we use the CHS method to read from the uh, memory, from the secondary memory specially. So I'm gonna here create a label called load kernel, and this label will be used to load the uh, kernel from the disk uh, into the RAM, uh, into the memory 80x 10,000. Okay, now we will define it. First of all, we will place the address in the AX register kernel load segment, and now we are going to move it to the extra segment, because the interrupt that we will be using uses extra segment and BX register to work with the segmentation. So I'm gonna move BX to contain the value of 0x00. Now ES to the BX will be 1000, and this will be 000. So this will eventually be translated to address uh, 10,000, right? Yeah. This will eventually be translated to this physical address in in hexadecimal 10,000. And after that, we are going to define the read sector. So our bootloader is in sector 1 and our kernel is in sector 2. So I'm gonna do move AH to have the value of 02. So this will be used to read sector. And now we have to define the number of sector we need to read, and this will be defined in AL. So we want to read only one, that is only we want to read kernel. So I'm gonna define already what we have made, so kernel sector. And after that, we have to define the cylinder, the sector, and the head. This is like the uh, where in the hard drive or in the magnetic tape in the memory the kernel is located it. So for that, just follow the instruction ch to contain 0, and then move cl to have value 2, it is sector 2, and move dh to have the value. This says that head is 0, head 0. And now we have to uh, we have already done that, but for safety we will again move dl to have the value of bootloader. uh, I'm just making sure that while the code above here has not disrupt the DL. So if we have used DL in any of the code above here, so we need to do this, but we haven't done it. So this is just another unnecessary line. So, but for the sake it, I'm just writing it over here. And now we need to uh, call the BIOS interrupt that will help us read from the disk. So the interrupt is 0x13. Now after that, it will read from the disk and write us to the 0x 10,000 address. But if it fails, it will enable the carry bit. So if it is uh, if we get error, then we will jump to a label called disk error, and we will make a label called disk error. And here we will print to the screen using our 0x10 interrupt. So I'm gonna move AS to contain the value of 0x0E, and move AL, the number, the character E, and we'll be calling the interrupt 0x10, and then we will halt. That is the thing, if we cannot read from the disk. But if we can, then first of all I will erase whatever I put in the ES in the extra segment register. And so we are gonna move AX00, and then use move again to fill it with AX content. Now that after completing that, we will jump to the load GDT. So that means after we loaded the kernel, we will jump to the load GDT. So let me make this like a bit neat and clean so we can read it properly. Okay. So also one thing I need to explain, in the previous video, the mistake that I made was like I have already corrected it over here, but this was like this. So we had two label representing two different address like GDT null and GDT null, but this should be GDT 64. So after that I can erase that this comment. And also there is some mistake. Okay, for the 64-bit pointer, I have the starting of the global descriptor table should be defined in quad, not in the double word. So DQ over here, and this will be fine afterwards. So that is the only problem. And here we have the boot signature. It was always hidden, so I didn't see from the starting of the video until now. I haven't seen it so let's fix the space over here so we can see it clearly. And now that we have done it, so in the next video we will write our simple kernel and simulate the booting process. Then I think our bootloader making series will be finished, like if our booting process works fine. And what we can extend this video up to is like we can set up like cross compiler to write the kernel in C. And so what cross compiler is, like it is a version of GCC that compiles like 64-bit assembly x86 assembly code, but it produces code with like no OS dependencies. So let's see, like if we want to extend this video we can do that, but for now I feel like the next video will be the last video for this series. So I hope you guys have learned something from this series. So I'm gonna stop right here and see you guys in the next video. Thank you.